Welcome in our session. Okay, my name is Radosław Schmidt. I work as Big Data Architect at GetInData, and my teammates and I would like to tell you about the migration of data platform at Play. For those of you who don't live in Poland, Play is one of the largest telecommunications companies operating in our country. We are working together, he has been cooperating together since almost beginning of our company. I mean that Play was one of first our clients. And we work together really close as mixed teams, so we building stuff together. Previous data platform at Play was built on top of Hortonworks data platform with some additional elements from us. First of all, we introduced Trino for fast SQL query execution for ad hoc queries on top of HDFS. Trino was installed on each Hadoop node in our cluster. We also have upgraded Spark to version 3. We was using Jupyter Hub as data science and machine learning environment. And to orchestrate our workflows, we was using Apache Airflow. Both tools were installed on single virtual machines. Our CI/CD pipelines was based on Jenkins. Sorry for that. Okay, but unfortunately, after the merger of Hortonworks and Cloudera, the Hortonworks data platform was no longer developed. So, company faced with the challenge of building the completely new data platform for their analytics. The following requirements were set for the new platform. We wanted something 100% open source to decrease our costs. Also, something cloud-ready to deploy it anywhere. Also, easy application deployment, environment for multiple teams, easy maintenance and development, more power and space for our data, I mean petabyte scale, better scalability and resource management, and of course, last but not least, secure. Our new platform should be really secure. And after considering all pros and cons, we decided there is no better way to deliver software than containerization. But what is the best way to build some container-based solution? Of course, Kubernetes cluster. So we decided to go with that. If anyone don't know what is Kubernetes, this is open source container orchestration platform, originally developed and built by Google, and later on donated to Cloud Native Computing Foundation. Kubernetes has become one of the most popular platform and tool to manage containers applications in production environments. As of today, our new platform that is already on production looks like this. You can see that we stay with HDFS, Hadoop Distributed File System, to store our business data, but we are also use Ceph as Kubernetes storage layer. Most of our data are stored in Apache Parquet files, and our metadata are stored in Hive Metastore. We use Apache Spark and Trino as data processing layer. All of our jobs are orchestrated, business jobs are orchestrated using Apache Airflow, but our technical jobs are managed using Argo workflows. On top of this, we are using Apache Superset to build our dashboard and work with SQL, and Jupyter Hub as data science and machine learning environment. I'm leaving the floor for my colleagues who will talk about implementation details. So let's play.
Hello everyone, my name is Tomasz Sujkowski and I am DevOps engineer, so I would like to share with you about the DevOps part of this project. So, after we finished proofs of concept, we changed some things. We realized that there are many components which needs to be managed by us. So we transferred some of them to be managed by other teams, by Play teams. And because of that, we could focus more on core application. From our point of view, these applications are related to data. We also installed some new Kubernetes application on production version of our cluster. One of the major changes was switching from Ozone to HDFS. So, in the final production version, components such as Vault, Ceph, Harbor are no longer be managed by us, but play teams currently are responsible for them. In such approach, we no longer need administrative privileges on Kubernetes cluster. So nowadays, responsibilities are better organized. Another things which we changed on the production version, it was integration DEX, which is authentication plugin in Kubernetes environment with corporate key clock to have single sign-on. We also start using Cert Manager for managing SSL certificates. For easier service creation, we use external DNS, and currently DNS records are dynamically created in corporate DNS. We also did some smaller changes, but we have limited time, so I wouldn't mention about all of them. But for sure, one of the most interesting changes was switching from Ozone to HDFS. At the beginning of this project, we had to choose storage for our data, storage which is on-premise storage. So we were thinking about Ozone, which is the successor to HDFS, and it is compatible with HDFS. It's also possible to integrate Ozone with Kerberos and Ranger. Ozone is an object store, so it has cool feature which is S3 gateway. We can use it to communicate via S3 protocol from client. But unfortunately, there were some problems related to Spark. We had problems with delegation tokens with Kerberos and some others. We tried to resolve them, but not all was. We spent some time, we debug even Java code, but not all was ideal. So finally, we decided to choose our old, well-known friend HDFS, because we need reliable and fault-tolerant storage. But, however, we're still thinking about Ozone. The current version is 1.4 from the beginning of this year, so for sure in the future we will go back to it. Oh, sorry. So, we choose HDFS as our storage. We realized that this project is still actively developed and new versions are released regularly. The current version is 3.4 from the last month. There were some changes compared to HDFS, which we know from old Hadoop clusters. And currently it is, for example, currently it is possible to have 3 name nodes. 1 active and 2 standby. We placed name nodes, Zookeeper, journal nodes, and Kubernetes control planes together in the same physical machines. All of these HDFS components are installed by Ansible scripts in fully automated way. It is possible to deploy Kubernetes as to deploy HDFS as Kubernetes deployment, but we decided to separate HDFS from Kubernetes, that any potential issues related to Kubernetes wouldn't affect HDFS, because, as I mentioned, this storage, data storage, is crucial for our project. Of course, security in companies like Play, which is telco company, is very important. So we Kerberized this HDFS and integrated it with Apache Ranger. More about Ranger will be on the next slide. For monitoring and alerting, we use Prometheus and Grafana, which is well-known tools in Kubernetes environment, and we use those tools to monitor other, not only HDFS, but other components from our cluster. The size of our HDFS is 1.4 petabytes. It's not so big, but also not so small. In our implementation, we also use Ceph as persistent storage for data, logs, and other persistent data. From our point of view, we treat this Ceph as, let's say, cloud storage because it's managed by other teams. One of the other important application in our cluster is Apache Ranger. We know it very well from old Hadoop clusters, and it helps us to manage authorization. It's running also on Kubernetes using Argo CD. Because this is Kerberized environment, we need K8s. So K8s and password are fetched from Vault. Apache Ranger needs components such as Elasticsearch for audit logs and relational database for metadata. We use Postgres as a relational database. There were some problems with, maybe not problems, but some work with compression and cleaning data in Elasticsearch, but we use simple scripts running by Argo workflow for that. So as Radek mentioned, we use also Argo workflow in our environment to use such simple scripts or, for example, backup scripts. Our Ranger fetched users from two sources, from Active Directory and corporate LDAP. Because in Kubernetes, it is easily to have multiple instances of the same application, we decided to have different instances of Ranger to HDFS and for Trino. There were some issues related to SSL certificates, but we started using Cert Manager, and nowadays, currently, we fetched this certificate from Cert Manager, which are signed by Corporate Certificate Authority. Another important application in our cluster is query processing, is Trino, which is query processing engine that enables executing SQL queries on large distributed data sets. It's a tool that provides fast processing on data from distributed sources like Hadoop, S3, or relational database, or any different sources. Some of you maybe know Trino because formerly it was known as PrestoSQL. We also run Trino as Kubernetes deployment from Argo CD. In the old Hadoop cluster, we were using Trino together with Hive, but currently we decided to have only Trino because it's more efficient and it's easily to implement it on Kubernetes environment. But it's not 100% true that we stopped using Hive, because Hive consists of two components, Hive Server and Hive Metastore. So we no longer use Hive Server, but we still use Hive Metastore. Hive Metastore is a repository which keeps metadata related to partition and tables. It includes the metadata such as table schema, data location, column statistic, and other attributes related to data stored on HDFS. Our Trino instance is integrated with Ranger, and for fetching groups, we use Group Provider plugin, and this plugin helps us fetching groups from LDAP and Active Directory. We also use in our Trino implementation Query Log plugin for analyzing audit logs. We tried to use autoscaler, Kubernetes autoscaler, but there were some problems. Unfortunately, Kubernetes killed some our Trino workers on which there were still active queries. So currently we stopped using them, but we know that there are different projects, and this autoscaler, there are some projects with autoscaler dedicated for Trino, so in the future we plan to come back to it. So that's all from my side, and I pass the floor to Cosma. Thank you.
Okay, thank you, Tomek. And my name is Cosma, and I would like to guide you through the rest of the presentation. which will be more from the developer's perspective, as I am a data engineer in a Play project. So let's start with user-facing applications, and I will tell you about Superset. Superset is an open source BI web app, which allows creating dynamic dashboards, visualizations, as well as an SQL IDE, which can be used for one-off queries. So currently, the tool we use is used only by a select few of our power users, but eventually it will be used by more teams, as it is an open source alternative to the paid solutions. So in order to onboard many more teams, we had to take a closer look at the security of a solution. And we had to think about how to manage permissions across different teams so that each team would see only their dashboard and no one else's. However, we also wanted to allow support for sharing dashboards across different teams if something like this was needed. So we found out that the Superset supports our use case. We were able to define connections for each team that were dependent on the Superset roles. And Superset also has support for sharing dashboards, so it works for us. Okay, let's move on to the Jupyter Hub. In short, it is a project that lets you spawn Jupyter notebooks in the multi-user environment with support for user authentication as well as custom user environments. In Kubernetes context, it means that we can, with help of Jupyter Hub, we can spawn Jupyter server pods with custom Docker images and such things as persistent storage. So Jupyter is integrated with corporate network file system, and it was a requirement so that the onboarding users from other solutions would be able to use existing workflows to move data in and out of Jupyter. In order to make this onboarding process easier, we wanted a good way to provide the Jupyter tutorials for them. So we found out about NB Gitpuller library, which was created with academics use in mind as a way for the instructors to pass the notebooks for the students. So this tool allowed the users to get the synchronized tutorials as soon as they request Jupyter server. So finally, we allowed vertical and horizontal scaling of the workflows. And for the so the users can either use Apache Spark for to compute the workflows on many different pods at once, or in case of the older non-distributed workflows, they can request a specific image that has more resources. So this is the startup Jupyter UI that is shown to the user, and it allows the user to choose image from the list, which the list is dynamically curated to the user based on what team he is in. So in Jupyter Lab, in Launcher view, we added the Superset button, and it makes the Jupyter Hub a sort of one-stop shop for the analytics to see all the analytic tools that we provide. If we were, for example, to add MLflow to as a tool, we would add it to this view as well. Okay, so moving on, we have Airflow. Airflow is a framework for creating workflows and scheduling them, and so it is basically a cron tab on steroids. So we can schedule whole workflow graphs, and these workflows may range from simple one-liner bash scripts to whole Spark ETLs to run. So our solution is set up as one Airflow instance per team. This solves us two problems. Firstly, permissions, as everyone in the team has access to everything, so we don't have to delve into the permissions. And it makes for easy upgradability, as every team can have its Airflow version upgraded at its own pace. As an Airflow backend, we use HashiCorp Vault, and it makes it so Airflow variables and connections are securely stored as Vault secrets. And one exciting feature that we are working on now is automatic Jupyter Notebook and SQL scheduling. So all the user will have to do is create a script, create a schedule, and our mechanism will take care of the rest. So this is in line with the trend of self-service, as it allows analytics to bypass data engineers when they want to create ETL, even if they might not have the necessary skills in Airflow. So to summarize, we have three user-facing applications: Airflow for the developer teams, and Airflow is for creating ETL and maintenance jobs. Jupyter Hub is used by developers and analytics for experimentation and one-off queries. And we have the Superset for analytics and management users for the BI use cases. So our tool for distributed computing is Apache Spark. And with its help, we can execute data engineering pipelines at scale. So before the migration, we had a lot of Spark ETLs and maintenance Spark jobs of varying complexity. So we were faced with a dilemma how to migrate these workflows as fast as possible. So eventually, we decided to stick with Hive Metastore, as all our DDLs were written in Hive, and our Spark jobs also expected the Metastore to exist. And I believe that this decision saved us countless work hours, and at the time when we really needed them the most. So we thought about a few solutions for how to execute Spark in Airflow, as it is a critical building block for us. And eventually we decided to use Spark Submit in client mode, as it solves us a bunch of problems basically for free. This is because log streaming to Airflow is happening very easy, as well as killing tasks from Airflow just works. Pod monitoring is easy, and again we have the question of upgradability, because each team has its own Spark version. It is easy to upgrade the versions one at a time. So we use Argo CD to deploy the applications, and it helps us in a few key ways. So first of all, we have code reusability, and we, for example, can reuse configuration files easily. And it also makes visibility easier. We know that everything that we deploy to the production is in this one big repo, and there should be no surprises on the production cluster. This in turn reduces the change inertia, because if we are not scared anymore of making large changes in production, and so they happen on a much more regular, even daily basis. So we keep all our infrastructure in one repo with the directory convention as shown on the slide. And this is the convention that is highly redundant, because a lot of files just are copied and pasted, but it is very simple to use, to maintain, to understand, and so it works very, very well for us. So that is the end of our presentation. We hope that you leave this talk with at least one interesting idea that you haven't thought about before, and if you have any questions, we will be happy to answer.
Thank you, guys. So I'm gonna pass the mic. Here you are. Yeah, round of applause, please. Come on, guys.
As I understood, you run most of your components in Kubernetes, but there are still some Hadoop components which you run outside of Kubernetes. Can you kind of explain which components you run outside of Kubernetes and why?
I mentioned about it. It's just only one component. It's HDFS storage, because as I mentioned, this storage is crucial for us, for our client, and this data always in such product is very important. So we want to have separate storage from Kubernetes, that any issues related to Kubernetes not affect HDFS. So HDFS is just separate from, but rest of this application like Trino, Spark, Airflow, and all of that stuff, Jupyter is inside Kubernetes as Kubernetes deployment.
Why did you decide to have 2 Ranger instances?
I also mentioned about that, but yeah, it's at the beginning when we had these virtual machines or physical machines, it was having 2 instances of Ranger. It was maybe not so difficult, but some work was needed to maintain and create another instance. But in Kubernetes world, it's easy to have multiple instances. So that's why we have 2 instances of Ranger, and we can, for example, upgrade one of them separately from the second one. So it was simple reason.
So I understand that you have a lot of open source applications running on Kubernetes, and probably also Kubernetes is maintained by you. And what about maintenance? How often you upgrade these components, and what is the process? Because it looks like a very complicated process.
But you mean Kubernetes version or application?
And also components which you integrate.
All components, yeah?
Yeah.
Okay. Yeah, it's a little bit complicated from this side, but actually it's not so complicated. But as we mentioned, this project was in Play company, so there are other teams from Play company, and they help us, for example.
It's not your problem, yeah, in this moment.
Sorry?
It's not your problem in this moment.
I mean, this, for example, Kubernetes version is still our problem, because we have to cooperate with them to check after upgrade if everything works fine, and we are responsible for application like Trino, Spark version. So yeah, it is a lot of tools, but
yeah, I'm afraid about,
there is no problem with upgrading.
I'm afraid about compatibility, yeah, in the future, because in this moment everything may work, but as you said already, you have some problems with versions, and what will happen in about 1 or 2 years from now, there might be a lot of problems from my point of view.
We will see, but yeah, nowadays, actually, it's, let's say, fresh migration, so you will see in the future.
So finger crossed.
Yeah, okay, thank you.
So we're gonna see your case study then next year, how it went.
Okay.
Okay, anyone with the last question? No hands
So
raised?
maybe all of us will be on this evening event, so maybe there will be more space for answering.
But I have one more question, and it's not gonna be so technical, but I've heard so many times that Kubernetes is the future, and it's better to switch to Kubernetes because in the long run, everything will run on Kubernetes, so there's no point in going elsewhere. So my question is, do you even agree with this statement, or are there any cases in your case that should not and will not ever be on Kubernetes?
Okay, I think we and our company will agree with that, because Kubernetes is a really popular technology in our company. We're using this tool in both environments, on premises, hybrid environments, clouds. You can deploy it everywhere. I think everyone should has own Kubernetes cluster, yes, in their home. So yes.